Hello everybody, it's Mr. Plunce. Hopefully my microphone's working this time. This is like the third or fourth time I've tried to record this video, so I feel like somebody does not want me to record this video. I don't know who, but all right, we're going to give it one more try and then I'm giving up. Okay, let's see here. The antiderivative, this looks like a review problem from that was on the last test. Okay, this is just review. So it's 2 over 2 x squared minus 1/3 x to the third plus c for good measure, but we don't need it because if you plug in 1 and 0, if you subtract, the c's will cancel. So let's see. So 2 over 2 is 1. Okay, so plug in 1. 1 squared is 1 times 1 is 1. Minus 1 cubed is 1 times 1/3. Now, when you plug in 0, you usually get 0, but double check. Sure enough, 0 minus 0 is 0. Now 1 is the same as 3/3 minus 1/3 is 2/3. So that was review. This is also review, same problem. Okay, so the antiderivative of 1x squared is 1/3 x to the third. Don't worry about the plus c. Plug 1 in, 1 cubed is 1, so it's 1/3. Double check that you get 0 when you plug in 0, so you get 1/3. Now take answer A minus answer B. 2/3 minus 1/3 is 1/3. Okay. There is a second way to get this problem. Instead of taking the integrals and subtracting later, what if you simplify first? So if you look at this problem, 2x minus x squared is here, and then x squared is here. Okay, so instead of subtracting later, let's try subtracting first and see what happens. I wonder if we can do it this way. All right, so we have 0 to 1. We have 2x minus 1 is minus 2x squared. Now take the antiderivative. So it's 2 over 2 x squared minus 2 over 3 x to the third. Okay, so if you simplify this, 2 over 2 is 1. Now plug in 1. 1 squared is 1 times 1 is 1. 1 cubed is 1 times 2/3 is 2/3. Now plug in 0 and you get 0. Oh, and I wrote the sign down. Sorry, wrong. This was supposed to be a minus. So that makes this a minus. Sorry about that. That's the minus there. Okay, so that's supposed to be a minus. Now we have 3/3 minus 2/3 is 1/3. Ooh, they're the same. Now, simplifying first is always easier. Simplifying first is easier. Sometimes by a little, sometimes by a lot. Okay, but it makes more sense to think of it the top way, which takes longer. Okay, so if we graph both curves, 2x minus x squared. Okay, so y equals 2x minus x squared. That's the same as negative x squared plus 2x. So I know it's a parabola that's upside down. Now, if I factor out a negative x, I'll be left with x minus 2. If it's in factored form, I can get the x-intercepts by figuring out what makes it 0. So 0 and 2, 0 and 2. That's a way of finding the x-intercepts by factoring. So then now if I plug 2 into a table, or I'm sorry, 1, if I plug 1 into a table, I get 2 minus 1 squared. I get 2 minus 1, which is 1. So 1, 1. Okay, so it looks like this. Okay, now The first integral I did way up above. So this integral up here. So 2x minus x squared. So that is down here now. So 2x minus x squared from 0 to 1. So I would have just found, so my bounds are from 0 to 1. So I would have found this area here. Okay, now the second integral was x squared. Okay, if I graph that one, y equals x squared. That's my second one. X squared, that's just a regular parabola that opens up. So that's this. Now, if I take a look at this formula here, from 0 to 1, the area below that curve, that would be this area that I'm taking away. So I'm subtracting that off. Now, if I subtract the area below the top curve minus the area below the bottom curve, what's left is this area between the curves. I get the area between the curves. Okay. So, to find the area between the curves, you need to know the left and right bounds and which curve is the upper and lower bound. Then this integral right there will give you the area between the curves. Okay, let's try it. Okay. So y equals x plus 1. That's a line. Plus 1 is the y-intercept and 1 is the slope. So it's right here. Now 9 minus x squared is an upside down parabola. So this is y equals x plus 1. This parabola is 9 minus x squared. X equals negative 1. Y can be anything as long as x is negative 1. So that's this vertical line. And x equals 2 is this vertical line. Find the area of the region enclosed by these curves. So the area is here. That's the area. Okay, so now I can set up an integral to find that area. So my left bound, my region goes from negative 1 to 2. Now it's my upper curve, which is 9 minus x squared, minus the area below my lower curve. My lower curve is x plus 1. So this is the integral that will find the shaded area. So I'm going to simplify this first. So I get 9 minus x squared minus x minus 1, which is, let's see, negative x squared minus x plus 8. Okay, now I'm going to take the antiderivative. So it's negative 1/3 x to the third minus 1/2 x squared plus 8x. Okay, now plug 2 in. 2 cubed is 8 times negative 1 is negative 8/3. 2 squared is 4 times 1 is 4/2, which is 2. 2 times 8 is 16. Minus, plug negative 1 in. Negative 1 cubed is negative 1 times negative 1 is positive 1/3. Minus negative 1 squared is 1. So that doesn't change, minus 8. Now be careful of all these negatives. This is negative 8/3. Negative 2 plus 16 is 14. Now it's minus 1/3 plus 1/2 plus 8. Okay, so negative 8/3 minus 1/3 is negative 9/3. Negative 9/3 is negative 3. 14 plus 8 is 22. Negative 3 plus 22 is negative 19. Negative 19 plus a half is, negative 3 plus 22 is 19. 19 plus a half is 19 and a half. Easy peasy lemon squeezy. Maybe not. At the end it got a little hairy with the fractions. There's kind of a lot of steps. It's sort of easy to make a mistake. Some of these can be a little bit of a doozy. Okay, let's try one more. Okay, this is a parabola that opens upside down. Negative x squared plus 5. The 5x. The y-intercepts are, we could factor out a negative x. We could get x minus 5. So they're 0 and 5. I could graph it accurately. Wait a second. You can sketch the curves if it's helpful, so we don't have to. We can. Maybe let's just do a really rough sketch. I know this is a parabola that opens upside down. Let me just rough. Okay. And then y equals x, that's just a diagonal line. So this is the area here. So what I need to know is where they cross these two bounds. Okay? Because I'm not given the bounds. So in the problem 1, I was given the bounds. See these bounds here? I was given. In this problem, I'm not given the bounds. So the curves must cross. So if I solve algebraically, I could substitute x equals 5x minus x squared. I will add x squared to both sides because it's easier to solve, and subtract 5x because it's easier to work with when the x squared is positive. So I get x squared minus 4x equals 0. Factor out an x. So they cross at 0 and 4. So 0 is there and 4 is there. So my sketch was just rough. It wasn't accurate. So what it told me is, one thing it told me, that the top curve had to be 5x minus x squared, and it just helped me visualize things to get started. So now my integral goes from 0 to 4. My top formula, the larger one, is 5x minus x squared minus x. Now I want to simplify this before I get started. 5x minus x is 4x. Okay, now I'm going to take the antiderivative, so it's 4 over 2, which is 2x squared, minus 1 over 3, x to the third. Now I'm going to happily plug in 4 and 0. So 4 squared is 16, times 2 is 32, minus 4 cubed, 4 times 4 is 16, 16 times 4 is 64, times 1 is 64 thirds. Then double check that when you plug in 0, you get 0, and you do. Now get a common denominator. So it's 96 thirds minus 64 thirds, which is 32 thirds, or 10 and 2 thirds. Bam, I am done. All right, good luck. So the sketch can be rough or accurate, depending on how hard the problem is, or sometimes it'll tell you to sketch it accurately, which means that sketching it accurately isn't that hard. So good luck and pay close attention to the details. This is due on Wednesday.